learning models. So what I'm going to be talking about mostly is classic TensorFlow, which is a cross-platform version of the main TensorFlow framework that will actually run on almost any platform. So the first big question that a lot of people ask is, why do you want to do machine learning on mobile devices? Isn't it something that you do on massive GPUs and TPUs in the cloud? And the big reason is usability. Interactivity is really key for all sorts of applications. My favorite example of this is actually the Google Translate app. They had, for several years, the ability to take a photo of a menu or a street sign in a foreign language, send it up to the server, and actually get the results back within a few seconds. But when they acquired the startup that was able to do real-time machine learning to do the OCR and to actually do the translation while you were holding the camera, and they added that into the Google Translate app, they found that people used that way more and people were way happier, even though the quality of the model was actually lower. And it was all because you actually got the machine learning into the kind of usability loop of people being able to just kind of point their camera and get instant results. So we see that with things like Google Keyboard, Snapchat, Google Photos, all of these things that are actually using TensorFlow and machine learning on device because they want to give users a much better experience. So that's really what's driving us when we think about this. We're working closely with a lot of chip builders and a lot of other external companies. Like, we're big fans of what Apple are doing with CoreML. We're keen supporters of that as well. And we're mainly focused on Android, iOS, and the Raspberry Pi. We do support other platforms to some extent, but these are the ones that we put most of our resources in, just because that's where most of our developers are actually asking us for help. And there's going to be a more detailed presentation on TensorFlow Lite after this. This is a version of TensorFlow which is much smaller than the traditional full TensorFlow. On mobile devices, the smallest that TensorFlow can get in terms of code size is about 1.5 megabytes. TensorFlow Lite can just be like 200 kilobytes of code, which is really important for a lot of mobile developers. Almost everybody I know is kind of bumping up against like the 100 meg limit in the Play Store, and similar kind of limits on iOS. So every sort of kilobyte really counts. So TensorFlow Lite is designed to be faster, easier, and smaller. It hasn't come out of developer preview yet, so what I'm going to be talking about is the full version of TensorFlow, TensorFlow Classic, we sometimes call it, which isn't as small, but it solves the problem of actually being able to take almost any TensorFlow model and run it on iOS or Android or the Raspberry Pi. I'm going to be running through these slides fairly quickly because I don't want to sort of, dive into too much detail. But I just want to give you an idea of what's actually out there, and the ability to ask the right questions and dig through the documentation on tensorflow.org. We integrate with Android Studio. If you're building for Android, you can actually build from Android Studio using Bazel. It's a little bit tricky because Bazel isn't a particularly widely used build system on Android. So there are actually some nice that you can actually, if you look through the Android Studio examples, you'll see there are actually some nice shortcuts where you don't have to jump through nearly as many hoops And I think anybody who's dealt with TensorFlow on Android previously will appreciate that. But what I really want to leave you with is kind of ideas of what you can do with machine learning on mobile, why this isn't just kind of a hype bubble. So my favorite thing to start with is just looking at some of the demos you can actually just grab for Android. This one is actually doing classification, the classic ImageNet, like what kind of object is in this picture. You can easily use the TensorFlow for Poets code lab, which allows you to retrain the model yourself without doing any coding and just supplying some of your own images to classify things that you want to try and classify yourself. So without having to do any sort of crazy machine learning stuff, you can actually just give it folders of images, and it will, in about half an hour on a laptop, retrain a model which will then try and recognize the kinds of things that are in those images, and then you can easily move it into the Android demo, and without really having to do very much coding at all, get your own demo that's recognizing things you care about. We also have the object detection API integration. So this lets you train your own bounding box recognition models and then use them within the Android app. And one thing I want to point out here is that we actually have, and the no training available yet is actually out of date. I should have fixed that. But the tracking actually is really helpful that we include there, because it means that as you're looking at bounding boxes that are like kind of moving around the video frame, you can actually tell which objects are the same object from frame to frame. So you don't have to do a lot of complicated logic yourself. And of course we have to do stylization, style transfer as well. So that just has a palette of different, I'm sure everybody is starting to get sick of this at this point, but you have kind of a palette of different painterly styles that you can apply to images, and the ability to train your own model. And just a little bit of technical detail. Because Android apps are using Java, we actually have a whole bunch of Java bindings that make it easy to use TensorFlow models in Android without having to jump through too many hoops. And you can see we actually have a bunch of pre-built binaries, so you don't have to do the horrible Bazel building stuff that I mentioned earlier yourself here. So for iOS, CoreML is a great solution if your model will work with the conversion process. If it won't work with the conversion process, you can still run it on the CPU using TensorFlow. We actually have some make files to help you build this yourself, but we also have CocoaPod support. So if you actually look for TensorFlow on CocoaPods, you can avoid all of this messing about with the building. And we do try and integrate as closely as we can with Apple's work, so we're using like the Accelerate library to try and speed everything up. Again, jumping to Inspirational Examples. This one will not win any design awards. This is my one of my contributions, but what it is the smallest amount of code possible to create a simple iOS app and run a model when you hit a button. So this is often the one I recommend people start with if they're trying to figure out, okay, what's the minimum amount of stuff I need to do to load and run a model in TensorFlow. If you want something that's a bit more slightly more aesthetically pleasing, you can also get the classification demo that we saw on Android on iOS. And these are all part of the TensorFlow GitHub project under the examples folder. And again, you can easily replace it with the TensorFlow for Poets Code Lab, which is doing transfer learning to easily allow you to recognize your own objects that you care about. And one of my personal favorites, doing things for the Raspberry Pi, actually while I was over in Europe a couple of days ago, I got to meet with the Raspberry Pi team, and it's not, it hasn't been, we haven't been talking about this very much, but we're hoping to actually in release 1.9 offer full pip support for installing TensorFlow on Raspberry Pis. This is still, sort of 1.9 hasn't come out of release candidate yet, so this isn't up on the tensorflow.org website, so you're getting a sneak peek. But the goal is to just allow people to install like libAtlas using apt-get on the Raspberry Pi, and then just do pip install TensorFlow and get TensorFlow up and running super easily on the Raspberry Pi. You could also cross-compile TensorFlow, because compiling TensorFlow on a Raspberry Pi takes forever, and it can take over a day. So I've actually put a bunch of work to getting TensorFlow cross-compiling for ARM on x86 Linux boxes, and have a Docker procedure for like reproducing that. So you can use some of the scripts that we include in the GitHub repo to benefit from that work. And we've also put in a bit of work to try and support even Pi Zeros, which don't have Neon SIMD instructions, and try to get TensorFlow actually running fast on those, because we've seen a lot of really interesting use cases with people taking sort of the $5 Pi Zeros and using them for kind of embedded use cases, which I'd imagine for the, a lot of, I've run into a lot of industrial use cases that might be relevant for some of the firms around Munich. And again, like the iOS and Android, we have some examples that do things like label image files. And again, you can actually train your own model using the TensorFlow for Poets Code Lab, and easily add that to the Raspberry Pi. And I also like feeding the output from that into the text-to-speech on the Raspberry Pi, so that you can run around with your Raspberry Pi and have it telling you what things are, which never really impresses anyone very much, because they're like, I know it's a chair, I know it's an apple, but I find it very satisfying. So that's kind of a really whirlwind tour through running full TensorFlow on embedded and mobile devices. What I'm really interested in seeing happen is finding out all of the things that you want to build and trying to help you use machine learning on all of these wild and wacky devices and build applications. So my email is petewarden@google.com. It's just my name, no dots, no underscores or anything like that. If you have any questions about TensorFlow, especially on the mobile side, I'm always happy to try and answer them when I can. We do also monitor Stack Overflow. If you're posting questions with the TensorFlow tag, that's another way of kind of getting hold of us. And come up and grab me afterwards and grab a sticker and tell me about what you've been up to. Okay.
I think now it's perfect time to ask all your questions that you had to TensorFlow Lite projects. No? Come on, I've seen you tweeting like on Stack Overflow.
So with all the examples you gave, we're still speaking about inference only, right? Or inference mainly. As far as I know, at least CoreML doesn't support training yet on the device. How far are we from actually training on the device? Is this a feasible thing, or is it something for the far future?
No, that's an awesome question. So Google Keyboard, actually, when you plug in your phone at night, it runs TensorFlow in a training mode to actually personalize the model that's running. So that's another really interesting use case. It's still not nearly as many people are doing training on device as are doing inference, but it's totally doable. There really aren't any massive differences in the calculations that you're doing during training. You just have to save out a version of the graph that has the backprop kind of flow in it, because the code to actually figure out how to do the gradients is only on the Python side. So you kind of have to run the Python to get the graph that has the training stuff in it, and then save out the graph def, and then manually kind of call TensorFlow to do the forward pass, and then do the backward pass, and then figure out how to save the because usually on a mobile device you don't have like a proper file system. You then have to figure out how to save the variable contents. But it's a very if you have a problem that requires it, I'd love to chat more and hear about how we can help.
I have a question. Yeah, as I said, I'm not familiar with anything with TensorFlow Lite, which is why I'm here. One of the questions is this, are you using RenderScript for the backend for the inferencing, or do you have something else? Because RenderScript has its limitations, especially talking to the...
Yes.
Yeah.
No, that's a great question. Another great question. We are not using RenderScript, mostly because what we found is that you really need specialized implementations to get hardware acceleration. What we are doing is actually a lot of the RenderScript team are helping with the Neural Network API on Android, which is a new API, a new hardware abstraction layer, which allows GPUs and DSPs and things like Huawei's neural accelerator that they've been putting out to actually expose, hey, I know how to run a convolution layer to programs on Android, and TensorFlow Lite will call into those where the drivers make them available. So it's been interesting that other like approaches to accelerators like Vulkan or GLSL and RenderScript haven't really been optimal for the neural network stuff, mostly because what we need to do is lots and lots of really big matrix multiplies.
Google has not allowed provided the drivers, even though there's been NVIDIA GPU in the device, with the exception of the Tango, there were no code drivers.
So yeah, no, that's a whole nother question, is like OpenCL and CUDA and all of these other ways of actually accessing accelerators through like accessing especially GPUs, and I feel like there's a whole history there that probably stretches way before I joined Google. And it's one thing I have definitely seen is that you don't always even with things like OpenCL, it's very hard to write a portable, optimal implementation of something as primitive as matrix multiplies. you sort of end up having to write your OpenCL with knowledge of the hardware that it's going to be deployed on if you want to get optimal performance. Well, but yeah. So that's why we've really ended up saying to people who know their hardware, like GPU manufacturers and DSP manufacturers, hey, just give us, convolutions and matrix multipliers that you write using a non-portable, your own assembler that you know how to do really well, and we will call that directly. Well, yeah, the neural network API has a set of primitives that you can use. I think it's like somewhere on the order of like 20 different primitives that are useful building blocks for neural networks. That makes sense. Cool.
Okay, so next one is...
No, that's good.
Thanks, that was really good. I couldn't quite hear all of that, so it might have been a bit answered already, but you mentioned you're going to, to Pi 0. The kind of next question is like, how low will you go? Do you plan to go lower than that?
Oh, yes.
Okay. Anything you can share already about that?
Yes, yeah. If you actually, I've been aiming, like my project that I'm putting a lot of my time into at the moment, and that we have a small team working on, is to use microcontrollers. Yes, I thought that might be. And what we're actually looking at is there's a board called the Blue Pill dev board, which is you can buy for like under $2 in single units from eBay. And it's an STM32 with a Cortex M3 with 20 kilobytes of RAM and 64K of flash. And my goal is to get a simple speech recognition example running on that, because we know from teams like the Google Hot Word team that you can actually run really useful, really effective neural networks in just like 10 or 20 kilobytes of space. Like, they're actually really well suited for running on embedded devices. So we want to demonstrate a kind of an end-to-end example to kind of evangelize this. And then hopefully most embedded applications actually are a little bit more forgiving. Like, you might have 100K and a slightly faster microcontroller. But if we can demonstrate that you can get down all the way to that level, I mean, really what I see is that as long as you have like some kind of 32-bit CPU, even if it's not fast, that's where I want to be. And I want to be also running with really low power. Like, I want to have, like, one of the goals, the targets we've set is we want to have a 50-cent chip that runs for a year on a coin battery doing voice recognition. So yeah, if you have interesting applications, I'd love to hear about them afterwards.
And there's also like super awesome blog post by Pete from last week or so, like about this topic. So go for that. Yeah.
Yeah.
Oh, see, now it's connected. Any other questions? No? About supported operations, for instance, and roadmaps? No? Okay, I will ask it. So, are there like any plans or roadmaps like for future of TensorFlow Lite and operations in general, basically? Because some of people were, I cannot see the face right now, but like also asking, like I was trying to transfer from like TensorFlow model and it's like not supporting anymore, and what is idea behind that?
No, and that's the big difference at the moment between TensorFlow Classic and TensorFlow Lite, is that TensorFlow Lite is actually smaller and much faster at the things that it supports, but it doesn't support the wide range of ops that you can do in TensorFlow. So our goal is to merge the two back together and actually have that wider ops support within TensorFlow Lite. We're just trying to make the right trade-offs to make sure that we don't lose all of the the things that make TensorFlow Lite light in that process. Like, it's actually quite hard to disentangle the TensorFlow kernels from all of the other like runtime code that's in TensorFlow. They weren't written to be kind of easily modular, so we're doing some engineering work to try and figure out how to make that happen. But we definitely want to have that's probably the number one like priority for us, is figuring out how to make TensorFlow Lite way more usable by having support for all ops.
Cool, thank you. Any other questions? No? Okay. Thank you very much for awesome answers as well.
Thanks, everyone.
Okay, for now we have like maybe 10 minutes technical break to set up also next speaker. If you go in for peers, you can also put your lightning talk inside of the spreadsheet. So let's talk in 5 minutes, 10 minutes.